So I don't have anything to copyright for the intro team, so just think of an intro team by yourself. Tom is climbing a 3 meter long ladder that leans against a vertical wall, contacting the wall 2.5 meters above the ground. His weight of 680 newtons is the vector pointing vertically downward. Weight is measured in newtons, abbreviated N. What are the components of Tom's weight parallel and perpendicular to the ladder? So we are given that the ladder is 3 meters, and the wall of the ladder is big as 2.5 meters, and that the weight vector of Tom is 680 newtons, and we have to assume that this is 90, that the angle between the wall and the ground is 90 degrees, or else the wall is unstable, just like my mental health. So assuming we have to tilt the axes relative to the ladder, we have to get the two components of Tom's weight, uh, that is parallel to the ladder and perpendicular to the ladder. So we are looking for the two vectors that are in indigo in this video. So we have to get phi over here, which is the angle of the vector relative to the x-axis, and we are already given that the angle between the ground and the vector is 90 degrees since all weight vectors go straight down mostly. So yeah, and then now we have to add that towards whatever theta is, uh, which is the ground relative to the ladder. So we have to add the two up and then subtract it from 180 degrees in order to get the indigo phi that's over here. So we're looking for theta over here, and you have to use a trigonometric function, an inverse trigonometric function actually. If you don't remember which trigonometric function you need to use to get theta, you have to use the most powerful of all anime moves. It's called Coca-Cola. So, in order to get theta, we have to use x sine because we are given the opposite side, which is the 2.5 meter wall, and the hypotenuse, which is the 3 meter ladder in this case. So we have to divide opposite over adjacent. So and we have to get the x side of that value. So we have to get the x side of 2.5 divided by 3, and then in my calculator it equals 0.98. Wait, that does not seem right. The calculators and fucking radians. So now we have to get phi. We already have the 90 degrees from the vector relative to the ground, and we already have theta. Uh, so we have to add 56.43 plus 90, and after that we have to divide that by 180, only because one half rotation around the whole unit circle is 180 degrees. So that leads us to phi being 33.56 degrees. So finally, in this video, we have to get the components of Tom's weight parallel and perpendicular to the ladder that he's on. And in order to do that, we have to get the magnitude of the vector and then a trigonometric function. So the trigonometric function will determine if it will depend if you're gonna get the horizontal component or the vertical component. So yeah, if you remember from trigonometry, you would remember that the cosine is horizontal and the sine is vertical, and you can go on from there. And all angles are relative to the x-axis. So in order to get the one that's parallel to the ladder, we have to get the horizontal component since the ladder is on the x-axis. So it's 680 cosine phi. But here's the thing: we have to make it negative because the vector is on the negative x part of the axis. So yeah, and then to get the one that's perpendicular to the ladder, we have to get the vertical components of Tom's weight. So it's 680 side of phi, which we calculated earlier. But again, it's also negative because the vector is on the negative y-axis as well. So both components are negative. So anyway, I forgot to put the negatives on my answers from earlier. So, anyways, please drop a dislike if you like this video. I say dislikes because dislikes are better than likes in my opinion, and dislikes actually means something to a video instead of a like. So, anyways, see y'all in the next physics problem, I guess. Okay.